Hi everyone, Miss Nelson here, coming to you from Chicago, Illinois. Today, to start our lesson, I want you to start by thinking. Imagine you are kidnapped. You are dropped in the middle of a desert at night. Could you figure out where you are in the world? By the end of the lesson today, you will at least be able to figure out your latitude. So, today's objective is: what is the relationship between latitude and Polaris? So in order to answer this question, first we have to talk about Polaris. Polaris is also known as the North Star. It is known as the North Star because it is always due north in the sky. And in fact, if you are anywhere in the northern hemisphere, you will be able to see Polaris in the nighttime sky. Lastly, we call it the North Star because it is located directly above our North Pole. Meaning if you were to follow that line of our North Pole straight out, you would directly hit Polaris, the North Star. In order to understand how Polaris can help us find our latitude, I've created a little diagram for you. So, in our diagram, first I'm going to label our latitudes. We have 0 degrees north, also known as the equator, and going up all the way to 90 degrees north at the North Pole. Here is Polaris. Now, I'm telling you this is not to scale. And when I mean this diagram is not to scale, I mean it's really not to scale. Let me explain what I mean. So, see that little blue speck? Yeah, the one right there. That's our Earth. And that big orange circle would be the size of our sun to scale. Believe it or not, Polaris is even bigger than our sun. In fact, it's 50 times bigger than our sun in diameter. So if we shrink that diagram down to this size, Polaris would be that big. Pretty darn big. So looking back at our diagram, that's what I mean that this diagram is not to scale. Polaris is so much bigger than our Earth. The other thing that's not to scale is the distance. In reality, the distance between the Earth and Polaris is so many millions of miles away. In fact, it's 433 light years, meaning traveling at the speed of light, it would still take 433 years to reach Polaris. It is farther than we have ever traveled in space. Still, though, this diagram can help us understand the relationship between latitude and the height of Polaris in the nighttime sky. So, here you can see the perspective from space and what the perspective would be, the observer's perspective. If our observer is at the North Pole, 90 degrees north, you can see, there they are, that Polaris is going to be straight above their head. In science, we measure the height of Polaris in relation to the horizon. The horizon is that line that separates the land from the sky. So in this case, Polaris is 90 degrees above the horizon when the person is at 90 degrees north. If we move the person to 60 degrees north to that latitude, you can see that Polaris is no longer directly above the person's head. It is at an angle. And that angle from the observer's perspective is 60 degrees. Now the star is only 60 degrees above the horizon. If we move our person south to the latitude 30 degrees north, that angle gets even smaller. And now from the observer's perspective, Polaris is only 30 degrees above the horizon. And finally, at the equator, the angle is so small that from the observer's perspective, Polaris appears to be right at the horizon. So, what have we learned? We've learned that Polaris's altitude, or height above the horizon, is going to be equal to the latitude. If we're plotting that on a graph, where latitude is on the x-axis, and the altitude or height of Polaris is on the y-axis, it would be a perfectly direct relationship. At 0 degrees latitude, or the equator, Polaris was right on the horizon. If we were at 45 degrees north, the height of Polaris would be 45 degrees above the horizon. And at 90 degrees north, or the North Pole, Polaris was at a right angle, or at 90 degrees above the horizon. Knowing this, we can always predict where Polaris is going to be in the nighttime sky if we know our latitude. So, what would be the altitude of Polaris if you lived in Mount Marcy, New York? So, go ahead, pull out your reference table, and flip to the generalized bedrock diagram page. If you need to pause this video to take out your reference table, go ahead and pause it. So the question again is, what would be the altitude of Polaris if we lived on Mount Marcy? So the first order of business is finding Mount Marcy, which is right there. Now we need to find our latitude. Latitude, remember, are the lines that go across. And so the latitude of Mount Marcy is about 44 degrees north. It's a little bit farther north. So, what would be the altitude of Polaris? About 44 degrees above the horizon. Because the altitude of Polaris will always equal the latitude of the observer. So let's establish some relationships of the location of Polaris with how we move. So what happens to your view of Polaris as you move north? Well, let's look at our pictures. When the observer, so our first picture is the observer at the equator, and then we have the picture, the observer at 30 degrees north, at 60 degrees north, and at the North Pole. So, if we start at our equator and move north to the North Pole, what happened to Polaris in the nighttime sky? Polaris got higher and higher in the nighttime sky. So, as you move north and as your latitude increases, the altitude of Polaris, or the height of Polaris, also increases. Now let's consider what happens to your view of Polaris as you move south of the equator. So now I have my observer on the equator, 0 degrees latitude. What happens if they went south of that line? They would no longer be able to see Polaris. So, if you pass south of the equator, you can no longer see Polaris. The reason that is that it is no longer in that person's field of vision. They can't see through the Earth to see Polaris. So if you move south of the equator, you will no longer be able to see Polaris. Now let's consider what happens to your view of Polaris if you traveled east or traveled west. So imagine we have our person on 30 degrees north and they traveled due east, meaning they follow that same line of latitude over here. And then they traveled due west, again, traveling straight along that line of latitude. Well, the altitude of Polaris would remain the same because they're not changing latitude, so their altitude of Polaris won't change either. It's always going to be the same angle. Lastly, why does the altitude of Polaris change if you travel north or south? Well, as an observer travels north or south, the altitude of Polaris changes because Earth has a curved surface. Our angle changes because we're moving along the curved surface of the Earth. Okay. Hopefully now I've convinced you of how important it is to find Polaris, to find your latitude. So if you were stranded in the middle of a field, but you knew Polaris was 45 degrees above the horizon, for example, you would know you are at 45 degrees north latitude. But when you're looking at the nighttime sky, how can you find Polaris? The first thing that you're going to want to find is the Big Dipper. This is a constellation of stars that tend to be really bright in the nighttime sky. They make a shape that kind of reminds me of like a big spoon or a saucepan. Once you've found the Big Dipper, at the end of the Big Dipper, or at the end of the spoon, we have what we call two pointer stars. And those pointer stars point straight towards the star Polaris, which is at the handle of the Little Dipper. The problem is that the Big Dipper can be in any direct or location in the nighttime sky. So, for example, your nighttime sky could look like this, where the Big Dipper is on the right. But again, if we follow at the edge of what the spoon of the Big Dipper would be to those two pointer stars, the pointer stars will still point towards Polaris. The Big Dipper changes its location in the sky over the course of the year, depending on the season. But as you can see, regardless of what time of year it is, always, if you can find the Big Dipper, those two pointer stars will point towards the North Star, or Polaris. So, real story, one of my best friends from college, Asr Nizami, went to the Grand Canyon. And when she was at the Grand Canyon, she was able to take a picture of the Big Dipper and the North Star, or Polaris. This is her picture that she posted on Facebook. Can you find the Big Dipper? Can you find Polaris? In order to help you out, I've decided to make the stars a little bit brighter so that they're easier to see. How about now? Can you find the Big Dipper? Can you find Polaris? As you can see, there are no lines in the nighttime sky to help you find the Big Dipper. But if you look carefully, you might still be able to find the shape. Yep, it is right there. That is the Big Dipper. And now, if we follow the Big Dipper to the end of the spoon to find the 2 pointer stars, those 2 pointer stars will point us straight towards our star Polaris. It's right there. See, you can find Polaris in the nighttime sky. The thing is that the Big Dipper is not the only star to move in the nighttime sky. In fact, in the course of a night, in the northern hemisphere, all the stars appear to rotate around Polaris. So, I'm going to show you a video of real footage, time-lapse footage, of the stars as they move over the course of the night. Let's watch. So, as you can see, these are how the stars move in the nighttime. But if we change the exposure, we can see that the stars will leave behind what we call star trails that show the motion of the stars over the course of the night. As we said, all the stars appear to rotate around Polaris. So, right in the center, that is where we would find Polaris in the nighttime sky. All right, now let's try some questions. So, the first question says, the diagram below shows the angular altitude of Polaris above the horizon at a certain location. What is the observer's latitude? So let's look at our diagram. First, you can see that our observer is right at that corner. That's where our observer's location is. I like to draw a little human to remind myself that that's where the observer is. And if we follow that dotted line, we can see that that is the light line of sight to Polaris. I like to draw a star where Polaris is to remind me that that's the star Polaris. So, we have a person standing on the surface of the Earth, and we have their line of sight to Polaris. This scale, as we can see for angles, goes from 0 degrees at the surface of the Earth along the horizon all the way up to 90 degrees. What is the height of Polaris? So first, we need to put more increments in our scale so that we know what value it is. If we follow the big lines, that would be 10 degrees, 20 degrees, 30 degrees, and so on, all the way up to 90 degrees. As we can see, that dotted line falls directly between 20 and 30 degrees. So Polaris is 25 degrees above the horizon. That means that our latitude, the person's latitude, is 25 degrees north. All right, now I'm going to give you 4 minutes to answer these other 2 questions. 2A, which actually has 2 questions underneath it, and 2B. Please use your ESRT, especially that page where we were looking at before, earlier in the lesson. All right, your 4-minute countdown begins now. All right, let's go over some answers. So, for the first question, in question 2, what is the latitude of each position? So for the first one, as we can see, Polaris is 43 degrees above the horizon. So our latitude would be 43 degrees north. If we wanted to find what New York State city is at 43 degrees north, we would need to pull out our reference table. So here's our reference table. And the first thing we're going to do is find the 43 degrees north latitude line, which is right here. There are a couple cities that are close to this latitude line. So you could have put Niagara Falls, Buffalo, Rochester is a little bit farther away, but I'd still take it. Syracuse or Utica. Any of those cities would have been a good answer because they are close to that 43 degree north latitude line. So what New York State cities are at 43 degrees north? Utica, Buffalo, all the ones we just listed. At all of those cities, Polaris would be about 43 degrees above the horizon. In the second part, we see that Polaris is this time 90 degrees above the horizon, or a right angle. What would be that observer's latitude? Well, if it's 90 degrees above the horizon, then the observer's latitude would be 90 degrees north. Remember, the altitude of Polaris always equals the latitude of the observer. And remember, 90 degrees north is the North Pole. All right, so now we've reached the end of our lesson. So as always, I have an exit ticket for you. My exit ticket is this: Dory from Finding Nemo is lost. And we need to help find Dory. So Dory peeks her head out of the ocean and can see beautifully the nighttime sky. She has 2 questions. She knows a little bit of earth science. So her first question is, which star is Polaris? Now, I've limited the options for you. The possible stars can either be A, B, C, or D. Which star is Polaris? Once you've answered that question, we can now go to question 2, which is, Dory pulls out a protractor that shows 0 degrees to 90 degrees. Using that information, what is the approximate latitude of Dory? You don't have to be exact, but be as close as you can be. So, as a reminder, question 1, which star is Polaris? A, B, C, or D? Question 2, what is the approximate latitude of Dory? All right, I hope you guys learned something. And I hope you guys are all safe and doing well. And I'll talk to you soon. Bye.